And so our journey begins. Whenever we say mathematics, we have a tendency to be overwhelmed. It seems such a vast subject where there is no beginning and there is no end, and certainly not a middle. The very thought of mathematics itself is perplexing. Most of my nightmares involve mathematics. I would be in an exam, of course, of mathematics. There would be a problem consisting of a long equation that I need to solve. Then I realize I don't understand the equation and I have no clue of what theory it is based on and how to come to an answer. My adrenaline level rises up in tension. I get a flashback about the times I skipped the various math classes. I realize that this has resulted in the predicament that I find myself in that particular dream, which I think is real. I'm filled with remorse for not having attended that particular class, understood that particular chapter. I have this sinking feeling of this unavoidability of failing this particular exam. Then I wake up. The excitement is so high that it usually takes me 1 hour of sleeplessness to enable the adrenaline to be flushed out my system. I'm sure that you too must have had such nightmares. Before I undertook writing this book and subsequently this particular chapter on mathematics, I always had this bucket list item of learning and mastering mathematics so that those dreams would stop haunting me. The truth is that when I was studying engineering, the math became too complex and I had other priorities. So I paid less attention and even skipped some classes that would explain those dreams. I did not do exceptionally well in mathematics in my engineering course, but I truly wished that one time in the future I would be able to pursue my bucket list item of demystifying mathematics once and for all. Amazingly, after I was about to complete the framework or outline for this mathematics chapter, those nightmares not only stopped, but now in the exam dreams, I could solve the math problems. I can now put a tick mark in that bucket list item of nailing mathematics. This point onwards is all about how I fulfilled my last wish with regards to my education. The first and foremost thing that you must learn about mathematics is that it's not disorderly in any ways. There is a particular sequence of mathematics. Even though we saw chapters distributed through our were 12 years of academic mathematics studies, there is a map of mathematics. By knowing this map, this subject becomes less daunting. A knowledge map is like any physical map. You are able to have confidence when you are lost. You can pinpoint on the map where you are and determine where you want to go. In the physical level, that might not be possible when we are lost. A map provides us with the other landmarks. Eventually, it helps us understand where we are and achieve our goals. So now let us explore the knowledge map, which is in the form of a tree in the case of mathematics. As you can see in the diagram, math can be understood as a tree. There would be the roots, then the trunk and the branches. As you can see in the diagram, the most basic or important part of mathematics is what we have learned as arithmetics. Just to remind you what it is, I've placed the operators plus, minus, into, and divide. The whole of mathematics resides on the rules and definitions, classifications of arithmetics. Then the two sides of the trunk consist of geometry and algebra. You might be out of date with what those two realms of mathematics are, so I have just placed some typical examples. In algebra, there is always an equation and there is a variable like x here. Then we have to find the value of x. That is in the simpler form. In its more complex form, arithmetics would include more variables of higher orders and longer equations to solve. However, the theme is always to find the value of some variables that meet certain criteria, which is basically the equation. Geometry has to do with various shapes and forms. It tells us about the properties of rectangles, circles, triangles, and so on. Again, that is the simple form. In the complex form, there will be complex shapes and forms that we have to find similarities and congruences, angles, and so on. Then from the combination of algebra and geometry, two other realms of mathematics are born. The fourth one is coordinate geometry, and the fifth one is trigonometry. What you have to understand is neither algebra nor geometry would have been possible without arithmetics. Yes, even in geometry we need to do additions and subtractions, like to find the value of complementary angles and supplementary angles in the most basic problems. This follows that both coordinate geometry and trigonometry would not have been possible without algebra and geometry. Now it is all going to make sense to you. Coordinate geometry is nothing more than algebra expressed in terms of geometry. The equations of algebra are placed in a graph consisting of usually two axes, x and y. Trigonometry is all about the relationship of the three sides of a triangle. Needless to say, this forms an algebraic equation. They usually consist of the terms sine, cos, and tan. They are nothing more than ratios of two sides. Since there are three sides, there are six possible combinations. Among them, three we have listed earlier. Basically, the objective is always to find out the value of one side by knowing either the value of two sides or one side and one angle. Again, that is in the simple form. In the more complex form, trigonometry is usually translated into waves, but that's a different matter. Still, the objective is still the same, to find the value of an angle or the magnitude of a force. Finally, we come to the sixth branch of mathematics, which is calculus. Everybody thinks it's coming out of the blue. Not at all. It is the product of algebra, coordinate geometry, trigonometry. Needless to say, arithmetic is also used. You will remember calculus as two parts consisting of differentiation and integration. As you can see in the diagram, calculus is best understood by a curve in the x and y axis. In the simplest form, all we want to do is to find out the rate of change at any particular point in that curve. That would be differentiation. Then we want to find the area covered from a point in the curve A1 to the other point in the curve A2. That's all. However, in the complex form, that curve that you see becomes highly complicated, and in this way we need various theorems that the seventh realm of mathematics develop. We are talking about pure mathematics. They rely heavily on calculus and the other realms. Mainly their goal is to have fun by devising more complicated problems and logical solutions. If they don't exist, they will invent them using the rules of arithmetic, algebra, trigonometry, calculus, and so on. There's not much use of pure mathematics. However, there must be some, or they must be always, without fail, logical consistency and no rules that were developed or discovered earlier can be broken. Then the eighth branch of mathematics is the applied mathematics that make use of what has been found by pure mathematics in order to solve real life problems. So that's it, the knowledge tree of mathematics.